This is our project on the heartbeat of coffee, testing how coffee influences our heart rates by Dori and Jensen.
If you've ever been around college students before, then you've probably heard some kind of comment or joke about them needing tons of coffee or energy drinks to stay awake or focus in class. Well, everyone knows that coffee includes caffeine, which is a stimulant that is associated with mood changes and boosts of energy. But not much is really known about caffeine's effect on heart rate. So for our research, we wanted to examine if coffee actually does have a measurable effect on heart rate. When it comes to coffee and heart rate, there are definitely a decent amount of studies and research on the topic. Take this study from UT Austin. The purpose of this study was to examine how energy drinks affect the circulation of blood flow in the body in comparison to coffee and water using two experiment protocols. In Protocol 1, caffeine doses from energy drinks and coffee were adjusted to participants' body weights to ensure a standardized comparison. And there were 15 participants that completed 4 separate test days in Protocol 1. They consumed a low dose energy drink, which had usually 2 milligrams of caffeine per kilogram, and a medium dose energy drink, and coffee containers with 2 milligrams per kilogram of caffeine or 250 milliliters of water. And with this, they took the heart rate, blood pressure, and heart rate QTC intervals before consumption and for 6.5 hours afterwards. Within the second protocol, participants consumed larger doses to reflect real-life intake. Another group of 15 participants consumed a 16-ounce energy drink, a 24-ounce energy drink, and a standard K-cup serving of Starbucks coffee. From both protocols, heart rate and blood pressure did not show significant changes following any beverage. But within Protocol 1, there was a slight increase in arterial pressure. In Protocol 2, no such changes were observed, which means data indicates that a small dosage of energy drinks, coffee, or water does not strongly affect heart rate intervals. In this study from the American Journal of Cardiology, they studied non-habitual caffeine smokers, which are people who consumed under 1 dose a day of caffeine and were aged 18 plus that were studied for this. Relevant medical conditions, medication usage, smoking, and alcohol abuse were exclusion criteria for entry. This study consisted of 10 subjects, 6 men, 4 women, ranging from 23 to 32 in age that were studied. They were randomized in a 3-way single-blind crossover study, and participants received either a single oral dose of placebo or 100 to 200 milligrams of caffeine dissolved in honey. A 4-day break period was mandated to minimize any potential effects of caffeine withdrawal. Well, on each study day, heart rate, blood pressure, alertness, and parasympathetic nervous activity, also known as PNSA, were measured before administration of caffeine or the placebo and within the period of 60 to 90 minutes after the ingestion. Well, this study found that heart rate did not change significantly following caffeine ingestion. In contrast, measures of cardiac parasympathetic activity taken 60 to 90 minutes after caffeine intake were significantly lower compared with the placebo. And our last piece of background research comes from the University of Iowa Department of Psychology. This is a narrative review that examined the effects of caffeine on blood pressure and heart rate, considering factors like tolerance, family history of hypertension, borderline hypertension, and hypertension itself. Both epidemiological surveys and laboratory experimental studies were examined, focusing mainly on healthy participants. The epidemiological studies found that results were inconsistent regarding whether habitual caffeine consumption chronically elevates blood pressure, which means that some studies found positive associations, some found none. So there wasn't really a clear conclusion to come to. With the experimental laboratory studies, caffeine consistently produced acute increases in blood pressure. However, heart rate effects were less consistent, possibly due to differences in measurement. When it came to tolerance, repeated caffeine exposure can lead to partial or complete tolerance to cardiovascular effects. When it comes to hypertension, individuals with hypertension or borderline hypertension may be more sensitive to blood pressure increases from caffeine. So, in conclusion, caffeine can acutely raise blood pressure and sometimes heart rate, but long-term effects are generally minimal for most people. Overall, epidemiological evidence is weak, and experimental studies suggest short-term but not chronic cardiovascular risk for typical caffeine consumption. So, for our experiment, we wanted to research the question, does drinking coffee in the morning increase your heart rate? And for our hypothesis, we think that drinking coffee in the morning does increase your heart rate. For our methods, we spent 10 days collecting our data. Dori, the test subject, woke up each day, took her heart rate using the cardio app on her iPhone at 10 a.m., then drank a Dunkin' vanilla iced coffee pictured on the bottom below the glass of water. It is estimated that the Dunkin' drink has about 184 milligrams of caffeine. It took about 20 to 25 minutes on average to finish the drink. After finishing the drink, she waited 10 minutes and then took her heart rate again, trying to observe a difference. Jensen, the control subject, woke up each day and took her heart rate using the cardio app on iPhone at 10 a.m. Then she would drink about a 10-ounce glass of water, which is pictured above the coffee image in this slide. After finishing the drink, she waited about 10 minutes, then took her heart rate again and recorded the data. Finishing the glass of water around would take about 20 minutes.
For this experiment, we used a standard error analysis chart to evaluate our data because we were comparing the change in heart rate before and after drinking/not drinking coffee and water. We were just doing the post heart rate minus the pre heart rate to give us, and then averaging those out to give us one single number that would have been the mean of each set of data. And so the standard error analysis was the easiest way to measure that. Our sample size was 2, which was just Dori and then me for 10 days. And in order to control the confounding variables, we made sure that we were measuring our heart rates at the same time each day, just so that there wasn't like a fluctuation of times in the days. And we also made sure that none of us had any kind of like medication history that could be affecting our heart rate. We also just wanted it to not matter that we had any like caffeine tolerances, because neither of us really drink coffee or energy drinks, and so we knew that we were at like a good ground level to do this experiment. Here are our first set of data tables from this experiment. On the left, we have Jensen's results of the pre-heart rate before drinking water and then post-heart rate 10 minutes after drinking water. And then on the right, we have Dori's results from drinking coffee. We have her pre-heart rate before drinking coffee and then her post-heart rate 10 minutes after drinking the coffees. And then this is our final data table of the differences in heart rate. We just took the pre-heart rate and subtracted it from the post-heart rate, and that got our change in heart rate. And on the left, we have Jensen's difference in heart rate, and at the very bottom, we have the average of those 10 heart rates. And then on the right, we have Dori's difference in heart rate for all 10 days, and then at the very bottom, we have her mean difference in heart rate change for those 10 days. And then here is our standard error analysis graph. In the first column, we have the average change in heart rate from drinking water. And then in the second column, we have the average change in heart rate from drinking coffee. And then we have the standard error bars and everything. The two mean difference in heart rates that we got from this experiment were 2.2 and 2.3. And although they were different, when you look at the standard error bars on our graph, they overlap with one another, which shows that the difference is not large enough and not significant enough to prove a true change in heart rate from when you drink coffee in the morning compared to when you don't drink coffee in the morning. For this experiment, we researched the question, does drinking coffee in the morning increase your heart rate? Our original hypothesis was that drinking coffee would increase your heart rate, and we proposed this hypothesis due to the general stereotype and idea that caffeine makes you quote-unquote jittery and gives you a lot of energy. However, through this experiment, we learned that our hypothesis was refuted.
For our experiment, we believe there were two major things we could have done differently. The first thing was we could have used a more accurate instrument to measure our heart rate. For this experiment, we used the iPhone app Cardio from the App Store, and in order to calculate your pulse/heart rate, it required you to put your 2 fingers over the camera and flash in order for the app to calculate your heart rate. Unfortunately, this may not have been the most accurate method, and instead we could have used something more like a Fitbit or another, like an Apple Watch, for some more accuracy. Another major thing we could have done differently was use a higher sample size, and with that, more so randomize the study. If we had randomized the study, that would reduce the effects of a possible placebo, and if we had more people in our study, we could have had way more data and sample to draw conclusions from, which would have given us a more accurate mean, average, and conclusion.
And then these are our references. Thank you for taking the time to listen to our presentation.